This GET lecture of engineering mathematics on topic linear differential equation is brought to you by lecturesforfree.com. Hey guys, this is the third part of differential equations. If you haven't seen part 1 and part 2, then I will recommend you to watch that lecture also before this. Okay, let's start and see what are the topics that we will cover in this lecture. First of all, we will see the first order linear differential equation. Then we will see the standard form of this equation, and we will see the solution of first order linear differential equation. After that, we will solve some GATE questions related to this topic. If you want to get more solved GATE questions, then you can download my handwritten notes from my website lecturesforfree.com. Then there will be a challenge question for you that about this topic. Then there will be a solution of assignment question that I have given in my previous lecture. So let's start with first order linear differential equation. As it's clear by its name, first order means highest derivative coefficient that will be present in that equation will be of order 1. As if you don't have idea about order and degree, then you can watch my part 1 of this series. There we have studied order and degree of differential equation. So first order differential equation means highest differential coefficient that will present in that equation will be of order 1. Okay, and linear differential equation means that are not multiplied together, means their degree will also be 1. Okay, let's see it by an example. Let's write an equation dy upon dx plus 5y is equal to 4. This is an example of linear differential equation because as you can see, this is the highest degree of this equation, highest order of this equation is order 1, that is dy by dx, and its power is also 1, means its degree is also 1. So it's first order linear differential equation. If it is multiplied together, means let's suppose it has a power of 2. Let's consider one more example. Dy upon dx is square plus 4y is equal to 0, let's suppose. So here its square term is there, so it will not be a linear equation. So although here order is 1, but degree is not 1, and because it is dy upon dx is square, so this equation is not linear equation, and this is not first order linear differential equation. This is a first order linear differential equation, and this is not the first order linear differential equation. So let's see what is the standard form of first order linear differential equation. This is also known as Leibniz equation. The standard form of this equation is, let's suppose, dy upon dx plus p into y is equal to q. This is the standard form of first order linear differential equation, where p and q are function of x, as we can see here, there are mainly two variables, y and x. Y is known as here dependent variable, and x is known as independent variable. In this equation, y is dependent variable and x is independent variable. So standard form of linear differential equation will be like this. This is the standard form, but dependent variable and independent variable may be changed. Means dependent variable may be x, independent variable may be y, dependent variable may be x, independent variable may be t, or anything else. So first of all, let's start with this, where y is dependent variable and x is independent variable. Then this type of equation, dy upon dx plus by is equal to q, will be known as Leibniz equation, and we have to find the solution of this equation. So to find the solution of this equation, we will multiply with a factor. We will multiply both sides with a factor known as integrating factor. Integrating factor. You probably familiar with this term, integrating factor. Let's suppose I am calling it as a R. Okay, integrating factor, let's suppose it's a R, and this R will also be the function of some arbitrary function of x. This R will be also the function of x. So multiply both sides with R. So you will get the equation R dy upon dx plus R into P into Y is equal to Q into R. Okay. So again, to simplify this equation, let's assume one more thing. Let's assume R into P is equal to dr upon dx. Okay. Let's assume this P is equal to dr upon dx. Why we are assuming this, we will see in the next step. Why we are assuming R into P is equal to dr upon dx. First, let's assume, and let's put this value of Rp in this equation. Then you will get R into dy upon dx plus, instead of Rp, put the value of dr upon dx. So here you will get dr upon dx and into y, and you will get is equal to R in Q into R. Okay, Q into R. So here if you will see the left hand side is basically the differentiation of R multiplied by Y. If you will know the multiplication property of differentiation, then apply the multiplication property in this, then you will get R first function differentiation of second function means R into dy by dx plus second function means y, and differentiation of first function means dr upon dx. So this is the left hand side of this equation. So we can write this as a differentiation of dy by dx of R into y, and that will be equal to Q into R. Okay. So now to find out the solution Let's put the dx here right hand side, then you will get d into r into y. D and differentiation of r into y is equal to qr into dx. Now to find out the solution of this, let's integrate both side. So let's put integration sign here, and if you will integrate, then let's put a constant here. So the differentiation and integration will cancel out each other. Then you will get r into y is equal to integration of q into r dx, and you will get a constant c. So this will be your equation of your standard linear differential equation, first order linear differential equation, or this is a solution of, or you can say, Leibniz equation. This is the solution. So here r is the integrating factor. Okay, so to find out the value of r, let's consider our assumption. What we have assumed here, dr r into p is equal to dr upon dx. Let's find the value of r from this assumption. Okay, rp is equal to dr upon dx. Let's write it. R into p is equal to dr upon dx. Again simplify it, so you will get p into dx is equal to dr upon r. Let's integrate both sides, so you will get p integration of p into dx is equal to log 1 upon r. Integration of 1 upon r is log r. Log means ln r means it is the log to the base e. It is log to the base e. Okay, log r. So its base is e. So you will get e to the power in left hand side and right hand side. Then you will get e to the power integration of p dx is equal to r. This r, where r is the integrating factor, and that is equal to e to the power p dx. Okay, so this is integrating factor, this is solution of this differential equation. But let's suppose you have some other independent variable, you have some other dependent variable, then this equation will change accordingly. Let's suppose we have a equation like this, where dependent variable is x and independent variable is y. Let's suppose dx upon dy is equal to dx upon dy plus ax is equal to b. Okay, so here independent variable is y and dependent variable is x. So here solution will be your x into integrating factor. Let's x into integrating factor is equal to integration of b into integrating factor, and here dy plus one constant c. Okay, and here integrating factor will be e to the power integration of b into dy, not b, a. Here it will be a into dy. Okay, integrating factor will be e to the power integration of a into dy, because here a, and in previous example you can see, if this equation here p is there, then integrating factor will be e to the power integration of p dx, So here instead of p, here a is here, so you will get integrating factor is equal to e to the power integration of a dy. Okay, so okay, if you will get another example like dx upon dt plus, let's suppose ax is equal to b, let's suppose like this. So here also you can see x is a dependent variable, t is independent variable, so you can change this equation according to this equation. You will get answer like this: x into integrating factor, then integration of b into integrating factor, and into, instead of dy, here you will get term dt plus one constant c. Here integrating factor will be your e to the power integration of a into, instead of dy you will get here dt. Okay, so let's solve some question, some good get question related to this topic. This get question is asked in 2011 for 2 marks. Let's see the question. The solution of this differential equation with the condition that y equal to 1 and x equal to 1 is. As we can see this, this equation is linear differential equation. So let's compare this equation with standard form of equation. Let's compare dy upon dx plus y upon x is equal to x. Let's compare this equation with standard form of equation, means dy upon dx plus py plus py is equal to q. If you will compare these two equations, then you will get p is equal to 1 upon x and q is equal to x. Now if you know p and q, then you can find out integrating factor. Let's suppose I am calling it r, and it will be equal to e to the power integration of p into dx. So here p is 1 upon x and dx. Integration of 1 upon x is ln, means log at the base e, and x, so e to the power log base e, means it will cancel and you will get the answer x here. Okay, e to the power log the base e x will be equal to x. Now write the solution of this equation. Solution of this equation will be y is equal to, y into integrating factor. Y into integrating factor is equal to integration of q into integrating factor dx plus c. Here integrating factor is x, so y into x is equal to integration of q. Let's see what is q here. Q is equal to x, so let's put the x there. X into integrating factor is also x, and then dx plus c. So y in x is equal to, it is x square. Integration of x square will be x cube upon 3 plus c. Okay, you can simplify it, cancel out this x, or divide, you can say divide left hand side and right hand side by x. Then you will get y is equal to x square upon 3 plus c. Okay, so you will get this answer. But when you will see the option, there is no term like c here. Okay, there is no term like c, there is only x terms is there, and there is no term like c. So how you will get the value of c? You will get the value of c by using this condition. Here one condition is given with the condition that y is equal to 1 and x is equal to 1. So apply this condition and get the value of c so that you can get the right answer. That is given in this option. Okay. Okay, let's see here. If we have divided here y, so you will get c by x here. You will get c by x here. Okay. Now apply the condition y is equal to 1 at x is equal to 1. So put y equal to 1 and x equal to 1 in this equation. So you will get 1 is equal to 1 by 3 plus c by 1 is equal to, so you will get c equal to 1 up minus 1 by 3 means 2 by 3. Now put the value of c in this equation. So you will get final answer is equal to y is equal to x square by 3 plus 2 by 3 and x. Okay. Now see the option, in which option you are getting this answer. Now see the option. As you can see, option D is the right option because you are getting the same answer. So answer of this question will be option D. Okay. So let's see the next question. In this equation also, you have a given a equation and you have given one condition. So let's again compare this equation with our standard equation. So you will get here p is equal to 2x, okay, q is equal to e to the power minus x square. So let's get integrating factor r is equal to e to the power integration of p dx means e to the power integration of 2x and dx means integration of a 2 is a constant, 2 will come out of here, and integration of x is the x square by 2, so 2 will cancel and you will get e to the power x square. This will be your integrating factor. You can write like this is equal to e to the power 2 into x square by 2, so this 2 will cancel and you will get integrating factor is equal to e to the power x square. So you can write this solution like y into integrating factor and is equal to integration of q into integrating factor. So here q is e to the power minus x square into integrating factor means e to the power x square. Here you can also write directly e to the power minus x square into dx plus one constant c. So here you will get y into e to the power minus x square is equal to integration of e to the power minus x square multiplied with e to the power plus x square. So this will be e to the power 0. E to the power 0 means 1, means integration of 1 into dx. Integration of 1 into dx will be x plus c. Okay. Now move this e to the power minus x square to right hand side. So you will get y is equal to e to the power, sorry, here it will be plus x square because our integrating factor is e to the power x square. So you will get here plus sign, and if you will shift this in right hand side, you will get here minus sign and you will get x plus c. So in the option you can see there is no term like c here. So we have to find the value of c by using the conditions given in the question. Here one one condition is given, means y0 is equal to 1. This is given. It means when x is equal to 0, then y is equal to 1. It is written, it means that when x is equal to 0, then y is equal to 1. So apply this condition in this equation. Put the value y is equal to 1 and x is equal to 0. So you will get 1 is equal to e to the power 0 is equal to 0 plus c, means you will get c is equal to 1. You will get c is equal to 1. Now put the value of c is equal to 1 in this equation. So you will get y is equal to e to the power minus x square in bracket x plus 1. Now compare with this. Now compare this with any options, with the options. Then you will see option B is the right answer. Option B is the right answer. Now let's go to the challenge question. So guys, this is a challenge assignment question for you. If you can solve this, then definitely let me know by giving your answer in comment box. If you can't solve this, then you can see my next lecture. There I will solve this. Okay. Now let's see the previous question. Let's see the question that I have given in my previous lecture. If you have already solved this, then also you can see this, because there may be some different methods of solving. Okay. So here in this equation you can see that this is a kind of this is not linear differential equation, but with some modification we can convert it into the standard form of linear differential equation. Okay, let's see how we can do that. Let's see the solution. So given equation is this: t into dx upon dt plus x is equal to t. Okay, so this is not linear differential equation, but if I divide by t, if I divide the t in both sides, then I will get an equation like this: dx upon dt plus x upon t is equal to 1. Okay, so now this equation is look like a linear differential equation. Linear differential equation, where you can say x is a dependent variable, t is the independent variable, and here if you will compare this with the standard form, then you will get like a p is equal to 1 upon t and q is equal to 1. So you will get integrating factor is equal to e to the power integration of p into here dt is here, so you will get dt. So e to the power integration of 1 upon t and then dt. Integration of 1 upon t will be the log t, log at the base e t. Okay. So you will get finally e to the power log e to the base log base e t is will be t only. So you will get integrating factor is equal to t. Now apply the solution here. Solution will be your, here dependent variable is x, so you will get here x into integrating factor is equal to integration of q into integrating factor plus one constant c. So x into integrating factor is here t, integration of q is here 1 and integrating factor is t, and then here dt will be there, dt plus c. So you will get xt is equal to integration of t will be t square by 2 plus c. Now divide both sides with t, then you will get x is equal to t by 2 plus c by t. Okay, we are dividing both sides with t, then you will get x is equal to t by 2 plus c by t. Now in options there is no c, so we have to find out the value of c by using this initial condition. Here one initial condition is given, x1 is equal to 0.5. Initial condition is given, x1 is equal to 0.5. This is given. It means that when t is equal to 1, then x is equal to 0.5. Okay, or you can say half, x is equal to half. So apply this condition to find out the value of c. Apply this condition in this equation. Put x is equal to 1 by 2 and t is equal to 1. Okay, so 1 by 2 is equal to 1 upon 2 plus c, t is equal to 1. So from this you will get c is equal to 0. C is equal to 0. Now put this value of c, means put c equal to 0 in this equation. So you will get final answer, x is equal to t by 2. This will be your final answer. Okay. Now let's see the option, in which option this is there. So here you can see option D. Option D is the right answer because we are getting same. Okay, x is equal to t by 2. So right answer of this question will be option D. Okay. Thank you guys for watching this lecture. Subscribe us and you can download my notes from my website lecturesforfree.com. There you will find more questions, more great questions, and you can ask me any question in my website also. Okay, thank you so much.